Hello and welcome. Let us keep on doing our model exam from past paper. The first one, consider functions f and g. Two functions are given. They are given in ordered pairs. So the first one, f at 0 is 0, f at 1 is -1, f at 2 again it's -1, f at 3 is 1. The first orders are domains, or we can say they are inputs. The second orders are the outputs, and the g also the same way. It's given g at 0, -1, g at 1, g at 2, it's given. Then what's asked? We are asked to find 2f plus f over g at 2. That means 2f at 2 plus f at 2 over g at 2. We are going to evaluate each of the function at 2. So first let's get 2f. This is f at 0. That means when we say 2f at 0 or 2f at 1 or 2f at 2 or 2f at 3, that means I'm going to multiply the range. For example, 2f at 0 means 2 times 0, which is 0. 2f at 1 means 2 times -1, because -2, because 2f at f at 1 is -1. So 2f at 1 means we will multiply the range part. So 2f at 2 means again 2 times -1, which is -2. 2f at 3 means 2 times 1, which is 3. So now when we are trying to solve this, what is this result? 2f at 2. 2f at 2 is here it is. The final outcome is -2 plus f at 2. F at 2, here it is. That's -1 over g at 2. G at 2 means when the input is 2. For g, when the input is 2, what will be the output? The output will be 1. So I'm going to take 1 down. So this means -2 minus 1. -1 over 1 is -1. So the answer will be -3. So which is A. Okay. The next question says the sum of the digits of two digit number is 6. Okay. Let the number be xy. Assume this is a two-digit numbers. We know that this is a tens place, this is the unit place. But the sum of the digits, that means x plus y, is equal to, given to us, 6. If the digits are interchanged, the resulting number is 18 more than original number. That means yx is equal to 18 plus xy. We are also given this information. Okay, the beginning information matters. What does it say? The sum of the digits of two-digit number. That means we have two-digit numbers, obviously, xy. Let's say the x is the tens place, the y is the unit place. Don't forget, xy can be written as 10x plus y. 10x plus y. When we expand a given two-digit numbers, it has tens value, tens place, and ones place. So we can say 10 times x plus y. We can write it in this way. And the other information, the sum of the digits equal to 6. That means x plus y equals to 6. And also when we invert or when we interchange the place of the digits, that means it will be a yx. It's given to us 18 more than the original number. Okay. But when we expand xy, we have to do the same thing for yx. So this expression or this box can be written, yx is the same as, again, 10y plus x, which is equal to 18 plus xy is the same as 10x plus y. For example, if you have a number 23, you can write it 2 times 10 plus 3. Okay, any two-digit number can be written in this way. If it is 57, let's say 57 means 5 times 10 plus 7. So when I have two-digit number yx, I can write it 10 times y plus x. When I have a two-digit number xy, I can write it 10x plus y. Okay, that means let me finish this part. Don't forget one of my equation here. It is one of the given equation. This is like, I can say one equation because it contains x and y and there is equal sign. So this is one of my linear equation, which is two variables. So let me collect it. Let me bring this 10x to the left. It will be negative 9x remain because x minus 10x. Again, let me bring this y also. It will be 9y, which is equal to 18. I can divide by 9 all. So negative x plus y is equal to okay, keep it. This is the second equation. I have one equation at the top. This is the second equation. Now these two equations can be solved simultaneously, like by adding. Remember these two, I can add them. If I add, what will happen? The x and the negative x will eliminate it, and y plus y will be 2y, which is equal to 6 plus 2 will be 8. When I divide by 2, y will be 4. If y 4, again bring the y here. So x plus 4 is equal to 6, so x is equal to 2. So what the number? It says find the number, means our number is original one. This is xy. So what's x? 2, and what's y? 4. So our number must be 24. The next one, we are asked to simplify. There is a number 2 square root of 72 means 36 times radical 2 the whole over 3 minus 2 radical 128 means 64 times radical 2. I'm expressing as a product of perfect square number over 4, which is equal to 6 over radical 2. 1 over 2 in the radical is the same as radical 1 over radical 2, which is the same as 1 over radical 2. So I can remove the bracket and I can write in this way, and I can rationalize radical 2 over radical 2, which is equal to 6 radical 2 over 2. That means 3 radical 2. So only this part. Okay, let me repeat again once again, just to make it clear. To the right side, what do I have? It is 6 over radical 2. It was. So let me do it with the other color. After this, you can multiply by root 2 over root 2, which will be 6 radical 2 over 2. That means 3 radical 2. Okay, now this is equal to 2 times 6 radical 2 over 3 minus 2 times 8 radical 2 over 4 is equal to 3 radical 2. This I can cancel out by 3. This will be 2. 2 times 2 will be 4 radical 2 minus here also I can cancel out. This will be 2 by 4. So again 4 radical 2, which is equal to 3 radical 2. So what do I have? This will cancel out, and then okay, that means the original equation was supposed to be corrected. It was supposed to be plus here, not equal to, because after it says simplify, there should not be like an equal sign, because left hand and right hand are already numbers. So if it says show that the two numbers are equal, it will be another equation, but it's not show that. Simply say simplify. It is an expression because there is no variable, everything is in terms of numbers. So this one is plus anyways, this is also plus. So what do I have now? I cancelled out these two, so finally what left? 0 plus 3 radical 2, which is 3 radical 2 will be the final answer. The next one, we have a matrix A and B, which is 3 by 3. Which one of the following is not true? Determinant of matrix A is equal to the transpose. That's correct. Obviously, this is one of the rule. Any matrix and its transpose, they will have the same determinant. Again, determinant of A times B is the same as determinant of A times determinant of B. This is also obvious. That's correct. But when you go to C, what does this says? Matrix B is the same as negative of A. This is the same as negative 1 times A. Okay, I can write it in this way. B, matrix B equals to negative of A, means negative 1 times A. So if we have this precondition, like this is if condition, if we know that, can we conclude that determinant of A is equal to determinant of B? No. The reason, B is equal to negative A. Remember, for example, if I have a matrix A, this is the determinant of matrix A. Yeah, determinant of matrix A, if it is a constant number M. So what will be the determinant of K times A? It will be K cube times M. Like if A is 3 by 3, if A is 2 by 2, it will be K square. It depends on the order of the A. So when there is a constant K, the determinant of the given matrix will be the K the power of N times the determinant of the original. Like it depends on the order. Now this time, since we are talking about 3 by 3 matrix, if the determinant of A, this is if the determinant of A is equal to M, this implies the determinant of K times A is equal to K cube times M. It should be. So now B is equal to negative 1. That means B is equal to negative 1 times A. So determinant of B must be, the determinant of B must be negative 1 cube times determinant of A, which is equal to negative 1 cube is negative 1. So that negative of determinant of, it was supposed to be negative of determinant of A. The determinant of B equal to negative 1, because negative 1 cube will give us negative 1. That's why. So they are not equal. The answer should be C. And D, if R is non-zero constant, R times, here is a rule, yes, indeed when it's written R times A, the determinant of R times A will be R cube times, yes, that's one of the rule, we said it. So the answer should be C. The next one, what is the equation of a tangent line of the graph? We have a function f of x is equal to e the power of negative 2x cos x. I better to write it like as f of x instead of y. It's y, it's given as y, but y is the same as f of x or g of x, you can say it. So at x is equal to 0. That means first we have to get it f of 0. When you substitute f of 0 means substitute 0, e the power of 0 times cosine 0. E the power of 0 is 1, cosine 0 is also 1, so this is the same as 1. So which is equal to 1. So we need to find the equation of the tangent line at 0, 1. The equation of the tangent line is y minus y1 is equal to m into x minus x1. We have y1 and x1. These are the first and the second order. So that y minus 1 is equal to m times x only, because x1 is 0 already, as you see. Okay. So to find equation of line, we have y minus 1 is equal to m times x. Okay. That means I'm looking for m. I'm trying to get the m. But the m is the same as the derivative of the function at 1. So let's derive the function. What will be the derivative of this function? We have to apply product rule here, because there are two functions, as you see, combined by multiplying. So e the power of negative 2x derivative times cos x. Okay, let me expand it. Let's use our space also. Don't forget, we'll try to find the derivative at 0. I mean, we need to find the derivative at 0, not at 1. So let's derive it. The derivative of x will be e the power of negative 2x derivative times cos x by product rule, the first derivative times the second, plus the first as it is times the second one derivative. That's the rule. Okay, f times g derivative means f derivative g plus f g derivative. That's the rule. So let me remove this one and let me continue. So what will be f derivative? Let's finish it. E the power of negative 2x derivative will be as it is, but the exponent derivative by chain rule, it will be negative 2 e the power of negative 2x cos x. Okay, what I did here, it has to be clear. Okay, e the power of whatever the derivative will be itself, but the exponent derivative will be negative 2. That's why I just kept negative 2 as a coefficient. cosine derivative is negative sine x, so I have to say negative of e the power of negative 2x sine x. Now next step, let's get f derivative at 0. F derivative at 0, when I say negative 2 e the power of 0 cos 0 minus e the power of 0 sine 0. But sine 0 is 0, so I can ignore this part. This is 1, this is also 1. So f derivative at 0 will be just negative 2. Because 1 times 1, 1 times negative 2. So y minus 1 is equal to negative 2x. When I reshuffle, or when I collect everything to the left side, y plus 2x minus 1 is equal to 0. So which choice containing these choices, this answer, which that is C. Next one, we are asked limits. To find the limit of 2x e the power of x minus 3 absolute value of x, the whole over x, as x approaching 0 from the left. In the number line, if 0 here, approaching 0 from the left means this side. When we are approaching 0 from the, this is 0 from the left. Approaching 0 from the right means this one. This is approaching from the right side. But there is absolute value x here. Absolute value of x, it has two possible outcomes, x or negative x. It depends on the interval. It will be x when greater than 0. That means when we are approaching 0 from the right side. It will be negative x when x is less than 0, or when we are approaching 0 from the left side. That means since our limit is approaching 0 from the left, so I need to consider the first one. I will take negative x in place of x here. So our limit now completely will be changed to x e the power of x negative 3 times negative x, the whole over x, as x goes to 0 from the left, which is equal to the limit of, negative will be positive, and then let's take out x common, 2 e the power of x plus 1 plus 3, the whole over x, as x goes to 0 from the left. Now this time what we can do, we can cancel out the x now. That was the problem, to substitute 0 now directly. We can insert now 0s directly. 2 e the power of 0 plus 3, that means to the power of e the power of 0 is 1, so 2 plus 3, which is 5. So the answer must be, it's C. The next one, when the expression is simplified and written in the form of standard form of complex number, so 3 minus square root of negative 16 plus, in bracket, 2 plus square root of negative 81, close the bracket, minus 2 plus square root of negative 144. This is the question. First of all, square root of negative 16 is the same as 4i, and square root of negative 81 is the same as 9i, and square root of negative 144, it is 12i. Hopefully, 16 is 4 when it comes out, 81 is 9, and 144 is 12. It's this one. But now, what is something new? There is negative inside. There is negative inside. The radical means at the end there will be I. That's our domain is a set of complex number. Since I know this fact, now let me insert everything what I have, and let me try to simplify, and let's try to remove the bracket. The next step, 3 minus 4i plus, in bracket, 2 plus 9i minus, again bracket, 2 plus 12i, which is 3 minus 4i plus 2 plus 9i. The first bracket removed directly, minus 2 minus 12i. So what are the like terms? The 3, the 2, negative 2. I can cancel this one, and then 3 remain. And then next one, negative 4i plus 9i minus 12. Negative 16 plus 9 will be negative 7i. I think so, yeah. So 3 minus 7i, so the answer should be B. The next one, again, it is the same kind of limit that we did here. So apply the same process. Approaching 0 from the left is negative x, so I will just leave this one for the viewers. The next question, what is the value of the integral x square root of 1 minus x square dx? This is indefinite integral, so which method is appropriate here to integrate? hopefully substitution, because the one in the radicality is square. When I derive linear function, I'll get, because outside the bracket there is linear x. So let's say u is equal to 1 minus x square. When I derive both sides, du is equal to negative 2x dx, but I need only x dx, so negative half of du will be x dx. Therefore our integral will be completely changed. Negative half take out square root of u du. That means negative 1 over 2 integral u the power of 1 over 2 du. That means negative 1 over 2 u the power of, when I say plus 1, 3 over 2 times 2 over 3, you know, over 3 over 2, but I will flip it and cancel this one. So negative 1 over 3, and what's u? The u is 1 minus x square, the whole the power of 3 over 2 plus c. That's going to be the answer, which is A. Yes. The last one, but not the least one, again limit. The limit of x square minus 1 the whole over 1 minus radical x, as x goes to 1. So to find the limit of this function, direct substitution of 1, it will bring undefined, it will be 0 over 0 form. So we have to rationalize the lower part, and the upper part I will factorize it. The lower part, 1 plus radical x over 1 plus radical x will be the multiplier, the rationalizing factor. So it will be the limit of the upper part. This one I will factorize it. The factorized form of this one will be x minus 1 and x plus 1, and there is a multiplier also, 1 plus radical x, the whole over the down part 1 minus x remain, you know, when I multiply these two, like a minus b times a plus b means it's the same as a square minus b square. So this one is like a minus b, and this one like a plus b. So a square means, you know, it's 1 square minus radical x square. So what left? 1 minus x. That's how the denominator part arrived or comes. So now what can I see as x goes to 1? What can I see? 1 minus x is found here, almost the same, but this 1 minus x I can write it as negative of x minus 1. We can extract negative and write it as x minus 1. Then simplify it. X minus 1 cancelled out, and don't forget the negative here, and then substitute now 1. 1 plus 1 will be 2. Again the second bracket also 2 over negative 1. That's going to be negative 4. So the answer should be D. This is some of selected problem for this video. Hopefully I'll be back with additional questions. Thank you.